First of all, my name is Mike Block. I'm with the Elite Additive. And first of all, I want to say thank you to Hal and for Darren for taking their time to come out and meet me at the location where we're currently stationed at. After seeing what the capabilities were in 3D printing, I was asked to come here and present, and so thank you all for coming out. And hopefully from this we'll kind of get a better understanding of the 3D printing industry, kind of where it started and where it's going, and then also get an idea of what we do at Elite Additive. So I'm going to try the mouse clicker, hopefully it works. But the state of additive manufacturing, a lot of it know it as 3D printing, but the actual name of the industry is additive manufacturing, much like CNC. We know what CNC is, but it's also known as subtractive manufacturing. So if you hear the word additive or additive manufacturing, it's the same. It's related to 3D printing. So just want to go back a little bit. What I want to do is I want to lay the context, a little bit of the industry and some starters, some innovators of it, where it had begun and where it's at today. That'll really help to lead into when I start talking about Elite Additive and what we're doing. So Chuck Hall is, this was the first ever 3D printer that was developed and invented by Chuck Hall. This technology was called laser sintering. So you see the system on the left here, it was connected to a computer. So what he had is he had a build substrate with a curable resin inside of there. And so from a CAD model, he was able to detect the surfaces of that CAD model. And then what that did is develop coating for the laser to be able to do what it needs to do. So that laser then sintered the layers, or print layers layer by layer. And then when the part was done, it would come out of this vat of material. And you had a three-dimensional object in a very short amount of time. So this is Chuck. Another one we've got is Scott Crump. Scott started Stratasys, or the FDM technology, which we have here demoing today, fused deposition modeling. So Scott was in his kitchen, and he was using the glue gun to make characters for his daughter, or little figurines, and the light bulb went off. And Stratasys started, they had their first modeler in 1992, and the idea was to be able to get concept models a lot quicker in the hand for proof of design than it would be anywhere else. And so as you kind of see the start of where they were at, in the beginning they printed with one material, and today they're in printers that are much more advanced, doing multiple materials in the print at the same time. And so a little bit about that. So Chuck and Scott are the innovators of the industry. Again, you kind of take a look at this, just again the history of the industry. It's been around for over 30 years. So a lot of people don't know that and understand that it's been around. It's just the last, I would say, last 10 to 15 years. It really started to gain traction amongst other manufacturers as a tool to be able to print models much faster. So today you see companies that are adopting the technology. I think the last time I checked, I think Deloitte University Press had mentioned that 72% of companies in the United States now utilize 3D printing on their product development process. And that continues to increase as the printers start to advance more in their throughput, their capabilities, and their materials. So I get asked the question a lot, when's the next technology coming out? Because a lot of us are spoiled by the smartphone industry with technology, and we look at this and we say, well, it's constantly changing. It's what's next? So we're afraid to invest in the technology because when we buy it, the printer's going to be obsolete. So if you take a look at this, the FDM technology and the other technologies that have been in the industry have been around for a very long time. And so actually last year there was a brand new technology that was introduced in the first 30 years. So it isn't, the way that it's changing and advancing is the printers have more throughput, they have better tolerance, they have more material capabilities, more print capacity. And so now companies are able to buy multiple printers for certain product lines that they can utilize 3D printing for full manufacturing, full volume manufacturing. Here's a video here. I've got a few videos I just want to show you, kind of again, just showing you the history of the industry, kind of where it was at, where it started with concept models and where it's going today. So to kind of decipher that video a little bit too, as Chuck was mentioning, the industry now is starting to work with hybrid materials. So companies that are formulating special formulations that companies can formulate for their products allows them to be more competitive with other competitors. These systems here, not all systems in the industry or technologies in the industry are able to do that, but there are technologies that will take third-party materials that are hybrid with an open source printer to be able to make materials that will last longer, will be resistant to fatigue. And so anyway, it just gives you a little bit of an idea. Now part of that, obviously it's a marketing video. There are some things that come along with this, with 3D printing, that still needs to happen. And so, this is the vision for them, but today 3D printing is, it's another tool for the manufacturer. So we have CNC manufacturers, other manufacturers that are using 3D printing as a tool for the development cycle. So they'll even go to as far as 3D printing an injection molded tool to verify their part within the same day for their client. And when their client has verified that design, then it'll go through to full production. So again, it's the way that it's going, yes, it's certainly disruptive. We're seeing it now with certain supply chains. Companies are now considering additive manufacturing more than they ever did before because of the speed and the cost that they can get it for, and then get it made here. So another technology I just want to show you here. This is a demonstrator composite technology from Stratasys. And so they're printing parts without support structures. Here's some applications. I'm going to talk about some applications in the industry now, and then we can go into kind of how Elite fits into what's been going on in the industry. So in the upper left, there's companies such as Cessna and Beechcraft that have 3D printers in-house that they are printing end-use components for. So if you're flying in a future Cessna, Beechcraft, or Textron aircraft, you'll see parts that are 3D printed. They're actually, what they're doing, they're 3D printing them and then they're painting them. The materials themselves are able to pass FAA inspection. So they have certain material properties built into these materials that make it suitable for aircraft use. The picture down the lower left, what companies are doing today, how they were originally design a part, what they do is they put in a optimized software, topology optimized software that will generate a part that's more structurally sound, more lightweight, actually more lightweight, but it still has structural sound to it. So make a part like that traditionally would be very difficult. So you're seeing a lot of that now in the industry, and a lot of companies utilizing this for end-use products. And there's the picture to the upper right. You're seeing low volume manufacturing in certain cases. Not all technologies in the industries are going to be suitable for that. It's really still geometry dependent and the size of the part to justify what the cost is going to be. And on the right side, medical, both on the right side and down here, both of these parts come from a DICOM file. So when you go into the doctor today and you get a scan of your rib cage or your hip, that DICOM file can be converted to a printable file. So when it comes to certain injuries, certain repairs that the doctors have to do, whether it's maybe the dental industry, or as you see here, the actual parts are 3D printed and then placed inside of the body. And so what this does is allows you a mock-up of something that would be very close to the original for better functionality. So another down below, car industry is using the technology for jigs and fixtures. Really 3D printing is in every industry today. And so many forms and different applications. So I'll give you a little background on Elite Additive. So I started Elite Additive here in Bemidji back in, it was November 2017. So the original focus for Elite was doing parts providing, being an incubator company for the local community and surrounding areas. Elite Additive is a very unique company. It's first of its kind in this area in what we can do for capabilities and resources. And so really my vision for Elite is to start as a parts provider but somehow move to manufacturing. And so wasn't really sure how that would come about just yet, but started off, and about 4 or 5 months after, I had a colleague of mine contact me, and he had notified me that he was leaving a previous company that he was at, but we started discussing of how this industry is going to advance and how can we support it. And so we started talking about manufacturing principles and how do we apply that to additive manufacturing in order for these companies to apply and integrate in order to do this the right way. And so we come up with the idea of working with production automation companies that we could work closely with and help users of additive manufacturing adopt that technology or those technologies to increase their throughput and part quality. So the previous videos you guys had seen, it's a lot of talk about, hey, we're at manufacturing and we're doing manufacturing, but really the thing that's missing here is applying production automation technologies on the back end. Yeah, they can pump parts out, but they're going to have a pile of parts and they're going to have 3 guys in the room. We've seen companies have up to 15 guys hand sanding parts. And they say, you know, we could use these guys somewhere else, but they're stuck hand sanding parts all day long. So our focus as a company is coming in, understanding their application and the technology that they work with, and then doing a benchmark process run for that before they invest in any equipment and technology. And I'll talk a little bit more about that as we move along. But we are stationed here. We are headquarters out of Bemidji, Minnesota. And so our offices are right now located, we're located at La Valley Industries. So we are there for SpaceWise right now. And so really the difference, I always mention the elite difference. So we are the first company in the additive manufacturing industry that's developed mechanical treatments for both polymers and metals. And what do I mean? Are any familiar with what mechanical treatment is in mass finishing? Okay. So what we're doing is we are coming up with recipes that are allowing us to finish parts in a matter of 1 to 2 hours. I've got some samples up here too. And the issues are the parts come off the 3D printers and they have print layer lines, or the parts are too rough, or they're not within tolerance for consumer acceptance. So we come in and we apply mechanical treatment to those parts to finish them to required needs, or are reaching certain RA surface finish of those parts. So again, it's really the difference for us is we are coming in and taking a look at what the application needs are, and then we are benchmarking that process out and then providing a proposal to that company of what they can do. It may start out with 10% integration of production automation technologies. It may start at 60%, but we have the capabilities from start to finish with our strategic partners to be able to help them for each stage of that growth. So we have really kind of the elite name is for us to be able to have you know, the right amount of experience that we do, and we work with elite partners. Our partners are companies that have been in business for 60 to over 100 years and very specialized in their area of expertise. And so we're really bringing in knowledge together from the additive side, from the manufacturing side, to really work together to be able to provide the right solution for companies' applications. So. Again, Elite Additive, we have over a decade of experience. We have a colleague, John of mine, who's not here today, but he has 30 years of manufacturing experience alone. And so really be able to approach companies the way they should be approached when looking to advance their capabilities with additive. So our mission is to help bridge the adoption of production automation technologies, and that's also through providing additional technical services, whether it be consulting, it may be consumable sales, it may be helping out with overflow 3D printing work, and so really our vision is the way that we understand and see the industry being in it for some time is our vision is really to help the industry advance to mainstream production. So. The production printers are there, but they still need to apply manufacturing principles and production automation on the back end of the printing process. So that's really where our niche and our focus and our skill set. Is there any questions so far? Good, good. So really our statement is, you know, when we talk to companies and we're at events and stuff, we really feel that non-implementation of manufacturing principles have slowed down the industry to mainstream production. And so it is really truly a mentality thing in the additive manufacturing industry. You do see a lot of manufacturing, hey, we're manufacturing, you're doing this, but there's really a lot that needs to go on with that as well that's not talked about. And so we feel that we have something that we can help companies apply that own rows of printers now to be able to help increase their throughput and utilization of the technology. So there's kind of current roadblocks we see. Non-mechanical treatment. We're seeing a lot of chemicals being used in the industry, not very environmentally friendly. And so we have something that is a very repeatable process. It is environmentally friendly. And so it's consistent. You know, it's technologies that have been used for a long time in the conventional side. And so what we're doing is we're just adopting and tailoring those technologies to make it fit with additive. There's a few other things I've got listed here, limited production volumes. Some printers that you see today, there's some high volume printers, but there's some that are not high volume, and so they really kind of have their own fit. Support removal, this is another thing. We're seeing support removal of certain parts. I've got an example up here with a soluble core that you guys had seen. This is an application where you can 3D print a soluble core and you'll wrap it with a composite part. So this is actually Joe Gibbs Racing part, and they have 3D printers, and they print 24/7 with soluble technology. And so what they're able to do is once they have a core or a master, they're able to wrap that in composite, and then they dissolve that core out in the middle. Today they're using very caustic sodas and chemicals to be able to remove that. It's taking a longer period of time, so we have solutions that we use are more organic and are quicker for the support removal process. A lot of companies are disposing of these chemicals are costing a lot of money, and depending on the state that you're from, it's very difficult. So if we can, we've got a solution for that too, where we step in and we help them with that. So just a few other bullet points I have there, but moving along. So this is the six steps of implementation. So if we work with a company that is working in, we also work with conventional manufacturers in Minnesota, but if companies that want to implement production automation technologies, there's six steps we take them through. And so these are the 6 steps that we have laying out here, and this is being able to properly take them from beginning all the way through. And you see at the start there might be design optimization. They may want to utilize additive manufacturing for their product production, and so the current design that they have may not be feasible for the specific 3D printing technology. So then we have to take a look at the design, and if they're open to changing the design of the product or adding a chamfer or fillet in certain areas to strengthen the part for the process, that's something that needs to be considered. And then we'll go all the way through, we'll help them optimize the print parameters, we'll do the benchmarking process, and then we'll start working towards equipment integration. So our strategic alliances, so in order for us to go about this, like I mentioned, we wanted to work with companies that are very specialized in their area of expertise. So Hammond Roto Finish has been around for 137 years. We had sat down with Hammond Roto, and we told them what we wanted to do. And we said, your technologies work. There's really not much we need to change, but we want to take your technologies to the additive manufacturing industry. And they said, we don't know anything about additive. We know the industry is growing. There's more companies that are adopting the technology. And so we saw a good relationship fit, and so that's what we've been doing. So we have access to Hammond Roto finishing engineers and their chemists as well for certain application needs. Abrasive finishing, they're one of our media suppliers. So when we sell a vibratory finishing piece of equipment for additive manufacturing, abrasive finishing has been around for 60 years, 65 years. And so they specialize in the media development itself, the vibratory media. So they are coming up with certain formulations that are compatible with the 3D printing technologies to be able to make it work. And so anytime we sell a Hammond Roto finishing system, our materials come out of abrasive finishing. So we're starting to see the media manufacturing industry as well come up with more hybrid abrasive medias. Even synthetics, which will help with less usage of compounds and other things such as abrasive pastes and stuff that clients wouldn't have to use otherwise. So current equipment, so you've heard the word mass finishing. When you hear mass finishing, you might think of vibratory tumbling. Really, mass finishing is the umbrella for many different technologies. And so the additive manufacturing industry, you run across a lot of different applications, and so a lot of different geometry sizes and parts. And so it's really key to be able to have a solution from start to finish. We run into certain scenarios where mass finishing is not a good fit for the application. So we may use something else, other high energy finishing technologies. We may even get into robotics. And so through Hammond Roto Finishing, we have that capabilities as well. So just kind of a smaller robotic cell, again, just kind of showing you it's a 6-step or 6-axis robotic system that we use. So if companies print a part and there's a certain area that they want to hone in their tolerance, they can set this up, and then somebody can run that part. The part comes off the printer. They may not need any finishing to it, but they have a certain area that's called out specifically that they need to do. Again, mass finishing isn't going to be a good fit for that. It might be a different technology, such as something smaller. What we're really getting into more, we are working with companies. There's a company that's basically working on autonomous manufacturing in the automotive industry. So what this does is, once the parts come off the 3D printer, the plates enter into a robotic cell. The robotics remove the parts from the build plate, and then the build plate then is sent out of the robotic cell. The parts are then sent to the finishing operation, and then the build plate resurfacer, plates are sent through there to resurface, and then the plates are sent back to the 3D printer to be reused again. So as companies are starting to get high in volume, what they're doing today is they're having to bandsaw these parts off of the build plate. So they're doing higher volumes, and so for them to be able to alleviate some of that and automate some of this, this has been a huge help to them and a huge interest. So. Waste management system. So a lot of these processes, mass finishing, they have waste that's involved with it, and so we have certain waste treatment systems that we design and tailor for that application. California is obviously big stickler on waste, and so we do have a company that we work with there that has a specialized waste treatment system. I think it's like a 4-stage filter system that they go through. So after the waste is done, I mean, it comes out like water. After we've gone through the whole system. That's something that we've also developed, and we work closely with Hammond Roto Finishing. Some applications for mass finishing. So the mechanical treatments that we're doing, we're actually, it's work hardening the material itself, so we can do this both for metals and or polymers. And so what we're doing is we're not removing material from the actual part, we're just taking the material and moving it and work hardening it. So that allows us to get better strength in parts. Some of the printing process creates porosity in the parts, and so that tends to compare that to injection molding. The parts are weaker, and so this allows us to be able to give, through the mass finishing process, parts some added strength. And we talked a little bit about the soluble cores and being able to remove that. And again, this is an aerospace application. It's actually an aerospace part. It's a duct for running air through the aircraft. And so before mechanical treatment, aerospace companies were sealing these parts with a chemical process. And so they knew that they needed to get something away from the actual chemical process, but mechanical treatment is a non-chemical process that allows them to seal the surface of this part in a short amount of time. And so this is a big application right now in the industry, is being able to seal parts that have porosity with a non-chemical process. And also too, I got some samples up here. So companies are doing higher volume. Instead of hand sanding the parts, not knowing how much material they're removing, we've got it set up where we've got a 1 to 2 stage process. So the parts can go through a cut process. We remove about 2 to 3 thousandths of an inch of material off of the surface. And then it'll go into a deformation process after that to be able to work harden the material and also give it the injection molded surface look to it. I think we got more textures. Automotive companies are now printing certain paneling for inside of the vehicle. So we can also do textures with this as well. So this is a big deal for automotive, to be able to 3D print textured parts and then also be able to finish them like this as well. So I think that's about it I got there. That's what I got there. So, any questions at all? Questions clear as mud? A lot of information, I know. So if you have any questions, feel free to come up and ask me about any technologies or capabilities. Be happy to answer them for you. And thank you very much.